environmental sort of et al. Church groups tend to call themselves. We also have, well, we had a couple other green team members here. We've got Carol up helping with the technology. And so this is number 2 of a green team presentation for October. The focus of this one will be talking about exactly what climate change is, getting into the science of it, and also kind of what weather is and the details. And doing that for us is our local hero when it comes to weather, who has been working with the National Weather Agency, NOAA. He'll explain what that all is in a little detail. For the past, I think I was told 28 years, and then has been coming with his wife Tracy and their now grown-up daughter here to this congregation for the past 24 years. So, and now to take it away, Clinton.
All right. Okay, yes, NOAA is, I've been with NOAA since mid-90s, so hopefully I have some knowledge to expand and share with you all. NOAA stands for the National Oceanic and Atmospheric Administration. However, if you are a person employed by them, we often refer to them as the National Organization for the Advancement of Anacronyms, because we like to make everything have some fancy little word that represents something. But yes, climate change. I'm going to talk a little bit about what is weather and what is climate change, because there's still a large confusion amongst the two. People will say, oh, the weather's changing, the climate's changing, this storm's based because of climate change. We hear that every day on the news, we hear it down the streets. So we'll go a little bit about what the difference is between those. We're also going to talk about what is climate change and some signs that we can see that are happening today that are giving us really reasonable assurance that changes are occurring. And we'll also talk a little bit about some of the changes that are coming up in the long run over the next 100 years or so. We'll also take a look at what's been happening in the Pacific Northwest and what we can anticipate for the Portland Metro over the next 100 years as well. And then, of course, we'll finish up, like Nancy said, with some questions and answers. Hopefully more answers, but I'm sure we'll have a lot of ambiguous answers that'll still not really completely answer the question that gets posed. So first up, what is weather? You all watch weather on TV, at news. They tell you what the weather's going to be today, what it's going to be like tomorrow. That's weather. It's what you're getting today, what you're getting tomorrow. It's what actually happens. That's weather. And it's based on very changeable things in our immediate environment. The jet stream, where's the storm track? Is it headed towards California? Is it into Canada? That determines whether we're going to have rain this afternoon or is it going to stay sunny. That's weather. All based on things that are happening right now and very much more to the minute or to the hour. We have a lot of knowledge for that kind of stuff. Now, weather patterns we talk about are pretty easy. Jet streams. We know if the jet stream goes way south of us, that means we're in the cold side of it. If you think of it as being a ribbon of air that divides the warmer air mass to the south and the colder air masses to the north. So if it goes south of us, we like that because that brings us our sunny, or our clouds, our rain, our mountain snows. If it goes north of us, like it has been doing now for some time, what do we get? Sunny, hot, boring weather for the most part, okay? And in fact, this little pattern, people have asked, why is this happening so long? Why? Because if you look at October, I think it's now 11 days or 10 days above 80. We normally only see 5 in October. And if we keep this pace, we may even break the latest we've ever had, 80 degrees, which is coming up in a few more days. But the reason being, if you imagine a river, a giant rock in the middle of the river, what does the river want to do? It wants to split and go around that rock. And that's exactly what's happening to us. We have this big honking rock stuck over the mountain west. And when it sits there, that big high pressure, everything is forced to go around it. And that's what's happening. Our storm track is too far north into Canada. And everything to the south has been suffering since about mid-June. All right, climate. Now, climate is what the weather has been like over a long period of time in one specific area. That's climate. It's based on all the weather during some 30, 40, 50, 60 years worth of collection time. Okay? This just happens to be the new normals for Portland that just came out not too long ago for the next, and you see, we know that normal climatologically over the last 30 years, that's kind of the average rainfall for that month. So that's what we would expect. Well, climate is what you expect. In October, we expect 3 inches of rain based on what the weather has been like over the last 30 years in the month of October. But again, remember, weather is day to day. Climate is a long period. So here's the 3 inches for October. These middle two are the extremes. So if you're looking at the screen trying to figure out what's going on, these middle two are just the extremes. So the wettest October, I'm sure some of you have been here in 1994, was our wettest October on record, when we got back-to-back days of 2.5 inches of rain. And our driest, notice 1988, less than 1/4 of an inch of rain. So this isn't unprecedented what we're having right now. But if you notice, that's weather. That happened short term. The long term, what we'd expect is climate, and that would be a little more. So here's Portland's climate. Based on all the period of record, this is what we would expect. Notice that in the summertime, we expect sunny, dry weather, and by late summer, we expect to see smoke from wildfires in the Cascades or California or British Columbia drifting into the area from time to time. If you look at fall, look at October, November, December, we get into the rainy season. That's typically what we would see in Portland. And then, of course, winter is part 2 of the rainy season. And spring, we finally say, hope. Well, we still have part 3 in the rainy season in April and May, but at least by June, there's hope that summer's arriving, and then we're back to the circle, back to the dry summers again. So that's our climate. A fairly long wet period, a fairly short dry period. Okay? Now, I like to talk, when I go to schools and talk with kids, they ask the question about weather and climate. Weather is an easy way to think of it, is the weather will tell us what to wear today. Climate, on the other hand, that tells us what kind of things we should keep in the closet. Okay? It's a nice way to think about it. Long term, we know that, like the map with the picture we just showed a little bit, rainy in this winter season means we probably want to have some umbrellas or coats, and by summer, we're going to be wanting to wear our bathing suits and sandals. So weather and climate, long and short-term type environment. Now I'm going to see if this works. So this is a very nice video. If it works, it'll be great. If not, we're not going to worry about it. Okay, this is a, yes. Hold on a second. The lovely things of TED Talks.
Have you given a TED Talk?
I have not.
You could.
No, you wouldn't want to hear that. It appears to be starting up, so hopefully it will come on here. It's unfortunate that it's not preloaded. I'd love to have had that. But the idea is we're going to be watching a video of a little guy here walking along, leaving his footprints. And, let me turn it up. Stop. Great, I have no speaker. Okay. Hold on a moment here. Dag. I don't think it's going to work because my screen is already showing it going, and I don't think it's going to work here. So we'll go on past a moment here. Sorry. Yeah, it got frozen up on me, it looks like. Unless he clicks the, can you click the arrow on there? I don't think it works. Okay.
Can I hold something for you while you're messing with it?
Yeah.
Oh, yeah, it looks great on his screen.
Maybe you can describe it to us.
Yeah, that's what we're going to do. I'm going to describe it to you. So I'm
Can
going to
you
kill that
act
video
it
so it goes
out?
back to where we were.
Pantomime.
Pantomime. Keep walking with the dog.
Okay. So that was unfortunate. But the idea is, cracker nuts.
No, okay.
We'll go to here for a second. All right, so I'm going to have a volunteer. Tracy's here, so she stood up. She's going to watch for a little bit. So if you could imagine the little guy is taking a walk from one side of the park to the other side of the park. That's not what he's doing, but the puppy dog is doing what? What is a dog doing to go walking? They're sniffing everything, sniffing there, going over there, wherever go. Thank you, Tracy. So what we have is the little dog's footprints are going up and down, but we don't know where the little puppy dog is going to go next, do we? That is the weather trend. We don't know where he's going for sure. But notice the footprints of the little guy who's walking were in a steady pace, weren't they? So based on his trend of where he's walking, we get a good idea of where he's going to be in the next few steps. And if we know that, we get a good idea of where that dog's going to be. However, the dog will still be doing his little wiggle wax back and forth. But what is the dog doing? In the most sense, he's still going the same direction as the guy. So the man represents climate, okay? Steady pace. We got a good idea based on the weather of what that little dog is representing our weather is doing. And what the weather is doing, the man's got to follow along that steady little climb. So it's a fun video. It's better to watch it on TED TV if you ever see it. I will pass it later. So let's continue onward. Here's climate change. It brings up climate change. So the whole thing about climate change, it's not an end-all event. We are shifting, and that's the whole thing about climate change. In the past, there's been confusion about what it talks about, but essentially, cooler, moister climates get warmer, or the opposite way, hotter, drier climates get cooler. We're talking about shifts in the overall climate pattern. Now, I have complained about people, and I've even quit some professional agencies because, or societies, membership things, but global warming has been misused so much. It's not really a good term to use. It came out during the 1970s and spread fast in the 80s, but basically they're assuming the whole world is globally warming up, and that's not quite the change. It's not quite true, because this is, as we talk here, a lot of people say, well, there can't be climate change because this area is getting colder, and that's the problem with global warming. It's kind of a bad insinuation. But we do know the global pattern has been warming. This is the Earth, 1900 to 2014. Since 1900, we basically warmed about 1.5 degrees. And notice where the warming is occurring. Land mass areas make sense, the tropics, but also the biggest changes, and that's what these colors represent, white, a little change, the darker red, big changes, are occurring in areas that typically are colder environments, the polar regions and the areas above about 50 degrees latitude. Some will say, well, why is that? Well, mainly this is the biggest culprit. This is the carbon dioxide, and you hear this talked about in climate. It does have cyclical changes based on ice cores from the Arctic and the Antarctic. But notice where we are today. You know, this is 400,000 years ago, 300,000 years, 200, fairly stable as far as where the peaks have been and where it drops back and forth, because it's based on nature and environments and everything. But recently, we are now off the chart. You cannot, someone cannot explain that strictly only by natural variability. If they did, we wouldn't have such a huge, sharp difference from the current going on. How do we know the climate is warming? Well, here we take it even farther back to billions of years based on ice cores and stuff. And this is a whole bunch of good stuff. But notice our overall parts of the carbon dioxide. Yes, it was huge way back in. But then again, think about 400 billion years ago. If you buy the theory, that's basically the beginnings when there's huge volcanoes all over the entire globe and we have a liquid lava seas. As the Earth cooled, that gets frozen up into ice and water and other things. But notice since about, 100,000 years ago, pretty stable state until we get to about here. And here's our current years, 2000, 2500. So this is about where we are right now. And projections say we're going to go up again and continue upward. Notice that is higher than we have ever been in a long, long, long time. And this is pretty reliable data for the most part. Same chart says the same thing we were just talking about. The variability, the black dark line indicates the observations of the Earth, the global temperature average. Notice it's been kind of stagnant till the 1930s and then starts rising steadily. The other colors, if we only look at natural and human factors only, that would be the blue shade. Let me take it back. If you look at the green only, that's the natural variability, would explain this kind of heating. And that would be fairly steady state or a slight increase. But once we add the human contribution, what do we get? Fairly nice match, but sometime around after the war, and especially in the 60s, we're on a runaway path. I'm going to show this nice graph. This shows the United States average temperature changes, their normal change over each decade since 1901. The 30-year normal is what we like to use. So watch what happens. What I want you to watch for is look who turns redder, who turns bluer. Redder means it's getting warmer, and blue is getting cooler. Kind of a quiet period during that period, but then we start seeing changes in the 60s. And we start seeing that's blue, kind of cool in the southeast, but look where it's getting warmer. In the west, this is 1980s, we're getting warmer yet. And finally, we have our most recent data. That cool area that was present there, look at everyone has continued to warm over the time, but the biggest warmings are where? In the west. West and the industrial north as well have had big changes. We could see that in the industrial northeast. The west area is a little different factor going on there, but there is something going on there as well. Here's the change in the last 30 years, kind of just taking that one graphic and looking at it overall. This is where the biggest changes have occurred. Again, the west is the big thing that stands out. What about rainfall? Have we changed rainfall for the most part? Yeah, we have. This has been the trends, and we've seen this year. In fact, all you have to do is look at Lake Mead and Lake Powell. This building is what, Pastor Lynn, 30 feet tall?
I don't have a clue.
So if you can imagine 4 of these buildings, 4 Ainsworth buildings stacked on top of each other. That's how much Lake Powell has gone down. Just since 1998, I believe, it's been slowly going down. But big changes in the last 5 to 10 years. And this is the biggest reason why we have turned much drier in the west and much wetter back east. So impacts from our climate change. Here's another one, ocean heat. And why do we look at ocean heat? NOAA likes to look at ocean heat because that is the amount of heat that's stored up in the water. If you ever go a hot day when you were a kid, it's a hot day in June, you say, I've got to go cool off. I'm going to go jump in a pool, jump in the water, or the river, or the pond, something. You go out there to the pond, you jump in, and you're like ice cold water. What the green earth is that? Well, water does not want to gain heat very fast. It's very slow to heat up. On the other hand, if you go swimming in October and it's cold outside, the water is still somewhat warm because the opposite is also true. Water is very slow to lose its heat. And in this case, when you have 3/4 of the world covered by water, it takes an awful lot of time to warm it up. But once it does, we have stored heat. And we've had an above normal amount of stored heat in that water for quite some time. And it's getting worse. But notice that the worldwide average of where the stored heat is. It's not equal everywhere. It's concentrated, and this has to do with the sea currents. There's an area along the south that seems to be fairly hot, warm water. This could be a combination of the fact that water is warming because there's less influence in the ice that's to the south of it. Could be the currents. The biggest things I've seen here, though, look what's off the east coast of Asia and the eastern seaboard. 2 big areas that I unfortunately don't know why they're that way. I just see the data that what's going on. Someone else has got to explain what's going on there, but I suspect these are a couple of major industrial areas. So what does all that mean? Well, ocean heat is important because it impacts sea level rises. As you expand water and warm it up, the molecules that are in the water tend to spread out a little bit. And so the water itself starts to expand out. So we call it thermal expansion. Just from that alone, the water's can't go into the earth anymore. It's got to go up. So that means sea level comes up. That's heat in the water is also going to drive storms that are out there already. We've seen that in the past. Not necessarily more hurricanes, not necessarily more powerful storms in the Pacific, typhoons, not more of them, but more intensity to them. They will either develop, they will develop at a much more rapid speed when they go across those areas of warm water. If we go back to this one picture here, there's an area, Katrina's across the Gulf of Mexico. There's an area in the Gulf of Mexico where the water temperature during the midsummer runs about 90 to 92 degrees. Hurricanes feed off that warmth because that's what builds those storm clouds. When Katrina was going across, she was about a Category 3. When it went across that area, within 12 to 24 hours, it went to a Category 5 storm. Ian had the same kind of explosive development when he got north of Cuba, was going across the area west of the Florida Keys. Went to almost a Category 5 storm. It was only 5 miles short of a Category 5 after being a Category 2 or 3 waddling around Cuba. So ocean heat is a bigger driver. And if you have big, intense storms, that means you're going to have bigger waves. And bigger waves, where do they go? They go to the coastline. So that's a big impact. Sea life relocation, coral reef stuff. Major impacts for coral reefs. We've seen it in North Australia, you've seen it in the Caribbean, where reefs basically are a lot weaker than they used to be, and we're seeing bleaching and blanching occurring with that. And of course, the big elephant in the room, with warm ocean water, any ice that's touching it's going to want to melt faster. So that's a big impact for those ice sheets and the return of the ice sheets during the winter season. Here's our sea level change rises. Again, like ocean heat, it's very, very variant as far as where the biggest sea levels are occurring. Since 1990, the average sea level for the world, global average, has come up almost 4 inches. That's quite a bit. Since 1880, we've seen about 9 inches of rise. Now, looking down the road, we can see on this globe here, the blue indicates the largest sea level changes during the last 30 to 40 years, and the red's the lowest. Is there anywhere that's lowering? Not really. The west coast of North America actually, this is unbelievable, the Pacific Northwest and British Columbia coast have actually seen the sea level drop. And we're not sure why. We're not sure if it's a combination of plate tectonics, where we're being forced upward because of the crust, the earth subduction zones. But that's the only thing we can think of that's causing that to rise up. The rest of the world, though, has been seeing a decrease for the most, or an increase, I'm sorry, for the most part. These are the computerized models that project where we might be based on emissions from the global community. Here we are now, 2020. This is where we've been. And if we have very low emissions, it means we've really cut our emissions back down to where we should be, a lot lower, then the sea level rise on average, we might see 1 foot rise by the end of the century. We could probably live with that. We could cope with that. However, what's the observed trend? This is the observed trend. We're tracking to see an almost a 2 foot rise over the next 80 years around the world. Now that's going to be variable because if you're in a basin that's warmer water with higher thermal expansion or a confined body of water, it could be higher. It's estimated that the United States will probably see closer to a 2 to 3 foot rise along their coast, and especially dangerous is a lot of that will probably be the Gulf Coast. The Gulf Coast cannot take a big sea rise. A lot of it's already low, and a rise that big means you're going to lose a lot of protection for the land area from the coastal Bay Area islands. Worst case scenario, and at the moment, is that we'd be way up here. There's a high 7 foot rise of the global average over the next 80 years. Now, if you ever go shopping, you're always watching or if you're on eBay, you're looking, oh, I'm going to buy that item. It's that price, it's that price, it's that price. You got your heart set on that. Then it goes up. You're like, well, I wasn't planning on that. Now I got to do something different. Climate change and weather is similar. We don't know all the answers yet. As we continue to develop more technology, get more information, more observations, maybe this is going to be actually a lot lower based on observations of the next 50 years. It could be higher. We don't know. So the one thing is, don't take any one trend and say that's what's going to be, because there's still a lot of unknown variables to deal with. All right, let's see. Here's what the sea level rises mean. We kind of already talked this about the ocean heat, higher tides. We all live around the Pacific Northwest. We go fishing. We hear about the fishermen, and there's a big thing we like to hear about called king tides. They make massive waves on the beaches. A lot of coastal erosion occurs when they occur, and that's basically when the moon, the sun, they're all aligned on the same side of the earth, and our tides are much stronger. If the water sea level is already higher, that means those tides are going to come farther inland. Places like Pacific City, it's only 5 feet above sea level at the moment. If we have a 2-foot sea level rise the next 80 years, and then you bring a nice storm surge in with a king tide, the city's probably going to be underwater for a couple of days, as opposed to where it is now when it goes underwater at the airport only. Right now, when the high tides come in, the airport at Pacific City goes underwater, and it's usually gone after about 4 or 5 hours. But here's the big thing. Nearly a third of the world lives in the area of threat of these higher sea levels. And it's not just places like the United States, not like New York and Miami. We're talking about massive populations in poor areas. Bangladesh and a lot of island countries are seriously going to be watching and need help. And that's going to be a big issue for us as humans, is figuring out where these people are going to go. Because if we don't slow things down, they've got to move somewhere, and someone's got to be ready to take them in. All right, sea ice. Another thing we watch gives us clues about climate change. The summer sea ice, as far as its extent over the northern poles, on average, it's dropping every decade. We lose a little bit more, a little bit more. And that makes sense because the ocean heat, remember we talked about that water being warmer. It doesn't have a chance to get reestablished. Since the 1940s, the average annual sea ice is down 40%. That's a lot. This is the average. You can see the Russia and Alaska and Canada and the Northern Europe. This line represents the average. The climatologically, take all the years in, that's where on average the sea ice would extend. This white is where the sea ice was at the end of the summer last year. So we're not looking at the winter ice, we're looking at the minimum summer ice. It's a lot less than it should be, and it's getting worse. All right, I took this picture, because I didn't take the picture, I'm sorry, I used this picture. It's a nice example of the glacier retreats. Same picture, same view, August 1941, August of 2004. This is the Muir Glacier in Alaska. Notice the ice is way out, but notice if you melt it back, there's where the ice used to be. And it's way back behind the canyon now. If you took all the glaciers of the world, the water that's been lost from them, they would cover all those glaciers in 90 feet deep of water. So that's a lot. Here's another picture. This one is the Peterson Glacier in the Alaskan Peninsula. And this is about 1917, 2005, the trend. Lots of ice. You can see the same picture of the mountain range in the background. But now the ice is all gone. You now have this, well, it's all gone, but it's still a lovely meadow, but still, it's come at a big price. But the problem we have to deal with is this last statement here. That melt is accelerating. It's one thing to have melt, but when it gets faster and faster and faster, it's almost a runaway event. All right. So those are the things we looked at in the past that have occurred, that have been occurring, and continue to occur. What about locally? Well, in the Pacific Northwest, we have averaged about a 2-degree change in temperature in the last 100 years. And these are the things that are occurring because of that change in temperature rise. We've been reducing our snowpacks. On average, we have some decent snowpack. But there's a lot of years where the snowpack that comes is not as high as it should be. The La Nina years we've had the last couple of years have been okay. Last year we managed to have a really nice winter of snow. But prior to that, we had some pretty rotten snow years. Not as bad as the 90s and 80s, but they're getting back again. The other problem we have to deal with is that snow that is up there is melting off at an earlier pace. Earlier in the season, that snow melt begins to take off, and it's melting at a faster rate. So that's going to be a problem with us, because as we melt our snowpack out earlier and faster, that's going to be less water that comes down the rivers as we get into midsummer months. We're also having distressed forests. Again, the snowpack's gone. The moisture that you would count on in June with melting snow, it's not there. The summer rains, we don't get much summer rain in the mountains, so those forests begin to suffer, getting drier and drier and drier, and we all know what happens as the forests get drier. We've seen that happen. And of course, our Pacific Ocean is getting warmer as well. Other impacts we've seen, and these are things that you could probably say, yeah, I've seen that happen. More warm nights, especially in July and August and September. The number of nights where we drop below 60 degrees, used to be lots and lots of them. At one time, we would stay above 60 at night, maybe 5 or 6 times a summer. Each year, we're setting a new record for how many days we stay above 60 at night. This last 2021, if I recall right, we had almost 60 nights above 60 degrees. This year is getting bad too. We also see a trend to having a wetter May and March and April. Now this is something we didn't think would happen. We knew, kind of anticipated a wetter winters because of the pattern changes, but we're seeing a shift, a climate shift, where the rainy season is actually extending into later spring a little bit more. So we're seeing wetter Mays, wetter Aprils. On the flip side, drier Septembers have been coming around. Again, that shift, everything's kind of shifting a month down the road. Now, we like that, sure, because it's great to go to the beach on a nice September day, but because we're drier in September, here's something to think about. We're drier in September, our snow melted off earlier, the rivers have gone down a lot lower than they should be, but who's using those rivers? Fishermen and fish. Side effect is that's going to be affecting migrations of animals and fish. If we have low rivers and if they can't get up where they need to be going, that could be a big problem. Slower start to our rainy season, hotter summers. We've seen that, hotter summers. Here's one this year again. And they start earlier. Notice how abrupt it was this year? Rainy, cool. We were 59 degrees. I think it was on the 15th of June this year. For a high temperature in Portland, 59. 10 days later, it's 102. And we said, hello, summer. And again, roughly a 100-mile shift seems to be what we're seeing on the West Coast. So whatever you want to see your future 100 years from now, look about 100 to 150 miles to our south. That's the climate we're probably going to be in, which means we're going to be more like Eugene or Roseburg's weather here. Eugene could be worse. They could be like Medford. And if you think about the crops we grow in the Willamette Valley, they're very sensitive to temperature. Hops, spearmint. 90% of the world's spearmint comes out of this valley. Hops, huge valley. If we get too warm and too dry, this is not going to be the area for those things to be growing in. They'll shift north and someone else will have to start growing them. Other impacts we've seen in the Portland area. This is an interesting one I want to show you. Now, I know you can't see the details on the side, but this is a graph of the temperatures over the next 100 years. And it went too fast on me, so I'll back it up. Maybe it'll go again. So this is between now and 2040, then 2040 to 2060, and then by the end of the decade, notice this huge rise in our average temperatures in the summer months. Right now, in summertime, we typically see our highs in the low to mid-80s. There's a small period, about 2 weeks, where we get into around 87. Now we're talking about June, July, August, and September days, and again, this is by the end of the century, being in the high 80s and low 90s for daytime highs. And we're not talking records. We're talking, that's what it's going to be like. For a town that that has a fairly decent population of people who are unable to get cool, don't have air conditioning, that's a big impact. Winter, not as much of a change, but there is something that stands out. Look at this number, nights, 35 to 45. Well, actually, both of them. This is an atrocious number here, too. We can't cool down. That's going to create a lot of stress for people. But night times, we're not going to see as much freezing temperatures, which means our growing season is going to get longer. If the growing season gets longer, what else is going to be out there surviving? Bugs, insects, pests, beetles in the forests, things like that that'll be able to survive longer and may not have that killing hard freeze to keep their populations in control. So temperature is going to be a big thing to deal with, obviously, here in the Portland local area. Keeping cool and other impacts we have. Okay. Higher river levels in the winter season. We know we're going to see more rainfall. Now, what's interesting, the rainfall we anticipate in the Portland area isn't just the sprinkly stuff like my daughter says creates sparkles in your hair and you have an enjoyable walk in the light rain. No, we're talking an increase of those heavy downpours that come in and dump 1-2 inches of rain on a day. Then we might go a week or two without much rain, and then here comes another big one with a really strong impact power. That's the kind of storms we're going to start seeing, those kind coming in more and more often. And because of that, and the snow melts, our rivers will be running higher. We'll likely see more lower end flooding as we get into the early spring months. On the flip side, come late summer, we have really low rivers again. That's going to be affecting our navigation up the rivers. People with boats are going to have to worry about hitting rocks and other submerged items, and also the impact on the fish and the animals. And before we end, we're going to have to talk about one other thing that's going to be happening. We always talk about in meteorology, well, that storm was really powerful. I haven't seen that one in 100 and some odd years. The Columbus Day storm, or the blizzard of 1990 that dropped 3 feet of snow in the Columbia Gorge and they were shut off for weeks, or the firestorms of 2020 and Labor Day weekend. Those are extreme events. We don't see those very often. They're more like once-in-a-lifetime events. But now with climate change and everything shifting, some of these events will be repeating themselves at a higher frequency, and that's where we're going to see a signal of climate change for us is an increase in these big events, a higher frequency of them occurring. All right, bottom line, not all doom and gloom though. There are areas of the world that actually will benefit from climate change. One of such areas is the Central African area of the world. The area, sub-Sahara area. That area is getting wetter. Southern Sudan, southern Chad, all the way across over to Mali, and that area is getting warmer. That means they're going to be starting to grow crops they haven't seen growing there in years or decades or centuries. They're going to be raising cattle or other animals on their land. They're an area that's going to be somewhat benefiting from our destruction. Places in the plains, the United States, Central America, the United States Central Plains and Southern Plains, they are going to be getting warmer and drier. There's no doubt about that. That's going to be affecting what they can grow out there. However, places in the Dakotas and the upper Great Lakes are not going to be as intensely cold as often during the winter months, so they might be able to start growing something new there. Not all doom and gloom, but there is a lot of doom in there, unfortunately. The climate change is real. There's no question about that. The big question is, how much did we have an impact on it? And there's obviously, it seems to be quite a bit as we get to learn more. But again, we are still learning more. We may be able to change things as we go in the future, and it's not too late to fix things. We can slow things down. We can mitigate some of the big changes. There is change that's going to happen. That we can't get away from. But at least we can try to work some. If you have a lot more questions about climate change and the monitoring of all the things we look at in the world, trust the science. That's the job. The government, the civilian government, is based on verification, observations, and scientific study up to the level of reason that we have at that time. So as we learn new things, we can change things. But it's a good place to go if you want to learn more about climate change and other things. So now we're at this point. I love this cartoon. I don't know if you can see it, but it has a gentleman standing up. He's rather irate. And the guy at the podium talks about things about the climate summit: energy independence, preserve rainforests, green jobs, livable cities, clean water. And this guy in the audience saying, what if it's a big hoax and we create a better world for nothing? I don't think that'll be the case. Anyway, that's what I have for you. Nancy, I'll turn it back to you.
Okay, you're free to ask for questions yourself.
I am free to ask for questions myself.
You're a
Oh.
great teacher.
I get to answer them as well. Okay, we do have a few questions in the audience, and I'm guessing anybody has someone online. I'm guessing someone will probably pass them to us as well. I don't know how that'll work. Carol has a question. Carol.
I'm channeling Ellen Yarnell. She's on Zoom and she's been asking me questions. She has 5, so I guess I'll start with the first one and turn it over to other people because that could take a while. Hang on one sec, please.
Can you do it in her voice?
Excuse me?
Do it in her voice.
Do it. I'm sorry. That's a skill I haven't quite developed, but I'll work on it. Okay, so the first question is, how are the hot sea surface temperatures in the North Pacific Ocean affecting our precipitation and our temperatures?
The warmer Pacific has definitely had an effect on us. All you have to do is stand outside on a summer evening here in the Northwest, especially if you're along the Columbia River in North Portland. Typically, we have that nice onshore wind that comes in the afternoon and cools us back down. The water temperatures are warmer offshore, so what happens is they kind of interrupt that sea breeze coming in off the Pacific, and it's kept at the ocean. So we don't get a cooling effect in the evening hours here in Portland as much anymore. That's one of the number one ones that's happening across us. The other problem is we have been seeing a lot more dense fog throughout the entire summer season along the coast. Typically could count on dense fog out there a few times, but it's been persistent a lot more often over the last 4 or 5 years where we've been stuck in having Newport quarter-mile visibility all day long in the middle of August. That's one of the big changes we've been seeing. As far as precipitation, it has been a hindrance to us because you want to see. Well, it's a mixed question, actually. It's a mixed answer. You want to see warm water off the coast to help energize any storm that's coming in, get a little extra boost with rainfall coming in. But because it's warmer, it tends to want to dry the air mass out as it comes in. So fronts that normally come in the late spring and summer months that are already kind of weak are now gutted as they come in. They don't have much any moisture to them as they come in. The summer is been affected, definitely, from the lack of cooling winds in the evenings and lack of rains. Winter season, on the other hand, haven't seen much of a big increase. The only thing we've been seeing there is somewhat milder temperatures at night on the coast. Okay, another question? Nancy?
Probably need the mic so people can hear.
Yes. So my question, and this is kind of a chemistry question, is we talk a lot about carbon footprint, carbon storage, carbon sequestration. My understanding is that carbon as a element is one thing. Carbon hooked up, as it likes to be, with another element like oxygen, that's the issue here. And I wonder sometimes, because we hear about, oh, we're not going to turn down certain forests because they're carbon storage. And, you know, I don't know to what extent allowing things to release carbon in and of itself means that somehow it's going to get together with 1 or 2 oxygen molecules and, you know, create havoc? Or is this really more just thinking about carbon dioxide that is emitted as itself?
Okay, decent question. I'm not a big expert on chemistry, but I don't think the carbon dioxide already has bonded with 2 oxygen molecules, so I don't think it bonds with 3 very easily. We definitely know it bonds with 1, that's carbon monoxide. Carbon dioxide is kind of one of those gases that's in the atmosphere that, yes, it can be regulated. There is a lot of it normally occurring, but the big problem we have is it's too much. It's like the kids at Halloween. They've got too much. The fact that we're warming the environment, means the tundra area has been slowly melting. The tundra regions in the north is a big source area of carbon dioxide traps. That carbon dioxide is being released now. Bind that with all the stuff we're producing out of factories and automobiles, that's too much. The earth can't deal with all of that. Plus we have all these other natural sources too. So as far as getting it back in the ground and all that stuff, I don't know a lot about that. All I know is there's too much carbon dioxide and there's really no good way to get rid of it that I know of quickly. Yes, Mr. Potter.
Thanks. I do know that there's more carbon in the environment now than humans have ever lived with. We've never lived in an environment like this. And, we're pretty young planet-wise, but your chart does show some high carbon levels, but humans were not alive then. I guess my question is kind of, you were really good about kind of the way science doesn't jump to conclusions. It keeps looking and thinking, and I can't remember which slide it was, but it's like, just remember, we're watching this. We don't know exactly what's causing this or that or everything. I guess my question is about kind of both personally, how do you think about that in terms of being sure about things and making decisions and asking for changes kind of, authoritatively, and also how people use that to be like, well, we just don't know nothing, and, it might be this way, but it might not be anything, as kind of an excuse for not taking action on this issue, and kind of challenging that maybe person to person or even in systems that are reluctant.
Yeah, that's a good question. We hear that a lot of times is, well, yeah, even NOAA, even, the USGS, whoever it is, may not know the answers, but how sure are you? Well, we do know one thing. All scientists agree, regardless of what field you're in, climate change is real. There's no debate. We are warming. There are signs we've warmed too much already. So in that point, I have no problem supporting the ideas that change is occurring, change is real. We have made an impact. It's now a big question of the indecisiveness, I should say, the unknown part is how devastating is it going to be? We know there's going to be changes. There's going to be some adverse effects, especially for those living in lowland coastal areas. The sea level rise one is one good example. Now, I may not know how much rain is going to fall at the end of the century per year. I may not know if we're going to be in the 90s or we're going to be in the 80s in the summer on average. But it's seems to be a pretty darn far-going conclusion that we're going to have at least a 1 to 2 foot sea level rise. The big question is, some of the computer models say we could see as much as a 20-foot rise. And that's just unfathomable. One thing that did come out, I didn't mention earlier, is NOAA was looking at some of the sea level changes and the melt from the waters out of Greenland ice sheets, the Antarctic ice sheets, thermal expansion, all these little things. And they have noticed that the rate of change in the sea level may be faster than what that picture you saw occurring. So it may very well be that we see some of those higher levels earlier than we anticipate. But as far as the unknowns, there's still a lot of unknowns in the exact changes, but we do know the sea level is going to be coming up some. It's a big question is how much is it going to come up? Yes.
You've been talking a lot about sea level change, but coming from a agricultural region in the Central Plains that you were talking about, can you talk a little bit about what the effects are going to be on groundwater and how that's going to affect our production and economy?
What part of the central part of the you said you're from? Nebraska, Wyoming. So you know the Ogallala reservoirs and all the other aquifers down there. The Plains states, western Kansas, Oklahoma, Texas, eastern New Mexico, eastern Colorado, that area is probably the most prone to saying, and this is based on what I see, and it's not the ground truth, of course, but it looks like we're on a trend to say goodbye to grain agriculture in those areas. because we're going to see a continued intensification of droughts over that part of the country. The lack of snowfall in the mountains, the early release of the snowfall coming out of Colorado and New Mexico mountains means the aquifer is not going to get filled as ideally as it should be. They're going to have lower impacts. That's going to have a much, rivers coming from that area will be lower. So reservoirs in those regions will have less water to deal with. So irrigation, supporting the grain agriculture going on there is probably going to be a thing of the past another 50 years from now. It's just not an ideal situation. If you go farther north, the reservoir aquifers will be able to keep some water, but they too will be suffering too. So it's not just the southern and central plains that will be suffering. That summer period will be drier for all of that region, but the biggest impact is going to be seen in the southern parts where we have the droughts back. There's some studies indicate that we'll see droughts kind of rivaling what we saw back in the 1930s. We'll have very back-to-back or 3 or 5 back-to-back years of really warm, very dry summers followed by very dry winters. And that's not ideal for that area. And that seems to be the trend we're moving towards in that region of the country. Yes?
You mentioned bugs and pests. And coming from the upper Midwest and living with the mosquitoes that exist there, I feel like I'm seeing more mosquitoes in Portland and in Oregon. Is that true, and is that likely to continue because of the higher winter temperatures and wetter springs?
As far as in the city of Portland, it's kind of hard because I know the city does a major spray activity to kind of knock down the big source areas for mosquitoes that are in and around the city. I don't know if they've knocked those down recently as much as they used to. That might be an increase of why we're seeing mosquitoes. But as far as the drier summers, the fact that that standing water is what mosquitoes love to go find is disappearing. We should see a decrease in those mosquitoes there. However, we will probably see more aggressive mosquitoes in the mountain country during the early spring months when that snow melt is disappearing at a faster rate and the ground's wet and they're out and about. On the flip side, Mother Nature has a way to adapt. Animals adapt. However, a lot of the larger animals take time to adapt, like us. It takes us a long time to adapt to changes. Large animals, depending on littler animals, such as birds on mosquitoes, will have a high day because they're going to have more food to eat earlier in the season. On the flip side, they may not have as much come mid-season when those mosquitoes are supposed to be there. So there's going to be a shift at everything. The whole food chain is going to feel an effect somewhere or another, depending on what happens to temperatures and water. But as far as bugs and insects, I think our biggest increase is going to be the agricultural areas and up in the mountain country where there's not as much help from humans to keep the bugs and pests at minimum.
I just want to make a comment. Having grown up in southwestern Nebraska, I've seen how this change has been happening. Part of it, not just by our carbon thing, but irrigation. That has, in southwestern Nebraska, it was dryland farming years ago, and then as more and more irrigation wells were sunk. When I was a child, one of my earliest memories was after church in Enders, Nebraska, which is a little community, driving over to see how far up the water in the Enders Dam had risen on the tower as the lake filled after the dam was built on the Frenchman River. The last time I was back there, we drove over to see, and that tower is almost totally exposed, and the Frenchman River is just kind of a little creek. The creek, not that river, but a smaller spring-fed creek where I was baptized at 10 years old. Dunked, not sprinkled. We don't sprinkle in Church of the Brethren. But anyway, it was, you could find pools of water, corners of the creek that were deep enough to baptize people in. You can step across it now. And it breaks my heart whenever I go back and see that. So I think one of the things that we're up against, not just in terms of coastal areas, where we're going to have to really rethink where we build cities. Rebuilding cities on coastal areas that are going to be greatly affected by sea rise is one thing, but we're also going to have to learn, as you said, as the agricultural belt has to figure out some other way. There's going to be so much political uprising as people have to find new ways to make a living. A lot of people are going to be displaced and have to find new ways to doing. So thanks, Lynn. You really set me up this morning to feel bad and discouraged. And I know it's not hopeless and we can do things, but I'm just saying it's going to be really hard.
Right, and one thing to keep in mind, if anyone's been back east this year, the eastern United States started off the summer really, really wet. And then this blocking high got built in July. And most of the rains in the central and southern plains shut off. They're now dealing with one of their worst droughts in a long time across that part. In fact, I was looking, showed Tracy a picture of the Mississippi River. If you want to see something discouraging, go look at the Mississippi River right now. Well, not right now, but on pictures. They're saying that Memphis has its 5th lowest level ever. And it's at the lowest it's been since the early 90s. Again, remember the dog and the man walking? Let's hope we're on one of the dog tracks where that weather will shift back and they'll see really wet. The thing to worry about, though, is the trend. Are we going to continue that trend of getting dry every year, or is this just a one-year blip and next year we'll be back to normal? Unfortunately, the trend says this is going to be more normal in the future. Yes?
Thank you. Just to add to it, I'm taking it globally, and you mentioned this, but specifically, I know of people in Tuvalu. Tuvalu has probably lost their whole country now. The last I heard, it was on its way out. Marshall Islands, where where I spoke, where you could see the ocean on both sides of the atoll that the most people lived on, it's gone or going. And a lot of people in Micronesia, Marshall Islands, anyone that's built on an atoll, they're gone, and it's already.
Yeah.
Ellen just sent me a text. No more questions from me. Well, Ellen sent me enough questions that we could be here all afternoon. So I would like a little sense of how long people want to go, because this is. One more question. Okay. Hang on here, please. When do meteorologists think La Nina will flip to El Nino? And maybe you can explain that, because I'm not sure that everybody on this is going to know what that means. Thank you, Clinton.
Yes, that is a question that was posed to me many times this fall already. We are actually, back up here, a La Nina pattern means we have cooler than usual Pacific waters offshore. When that happens, we have a jet stream that's farther south, and we tend to have more rain events coming into the Pacific Northwest, translated over meaning heavy snow for the mountains. We also get a better chance for snow here in the lowlands because the air mass typically for winter months is cooler. During an El Nino pattern, that is flipped. The tropical waters off South America are warmer. That extends out over the Pacific farther. We get a storm shift where the storm shift up here, the cycle, goes to California. We get an active wet October and November, but then California gets heavy rains for January and December. Then it goes back. Big question is, when are we going to get out of this? We're now going into our 3rd La Nina season. That's only happened a few times before. It does appear, though, El Nino will be back next year. So we either go into a neutral year or we're going to slide back into El Nino next year, which means a milder, drier summer, or milder, drier winter for us next year. But this year, it looks like we're still going to have a wet, in fact, I expect to have a very wet November for us, which is good news.
I will. Oh, you want prayer? Yeah, we probably need it. But I mainly just wanted to thank everybody. Thank Clinton, who is a great professor. I think you'd be a great lecturer. And I want to thank the Green Team again. Carol Pinniger, Nancy Hatch, Janet Morris, Beth Poteet, anybody? Cecil Prescott. Sarah Butler, who's in Texas. So thank you all for setting this up. We have one more in 2 weeks, and we very much appreciate all you've shared with us today. So let us pray. Oh, gracious and loving God, we have taken in lots of information. We give you thanks for those who made this time possible, and for all the study and the science and the knowledge that helps guide us. Gracious God, may we take what we learn and make use of it. May it guide our actions, guide our speech, guide how we live and what we do in life. Help us to speak out, to share, and to do what will help in caring for your creation. Bless all these people here. May they know that you are with us always. In Jesus' name we pray. Amen. Oh, and thank you, David, upstairs. Thank you. Hiding behind the monitors.
I want to let people know that our next one, 2 weeks from now, because next week is congregational meeting, is going to be optimistic. We're going to talk about the things we can do to help stop global warming and deal where in places where it's going to continue to happen. So please come back 2 weeks from now, same place, same time-ish, and you'll hear some good news.
Hi, Dave.